Hello all. Today in this video we will learn about NAND2TETRIS Project 1. My name is Sarvesh Chandak and I am from VIT Chennai. So in Project 1 what we will learn is NOT gate, OR gate, AND gate, XOR gate, MUX and along with that demux. We will be implementing all the codes in VS Code, so stay tuned. These are the gates. NOT gate. What NOT gate does it? It takes 0 as input and then returns 1 as output, and if input is 1 then it returns 0 as output. For AND gate becomes positive only when A and B, both the inputs, are positive. OR gate becomes positive when either of A or B or both are positive, and if both are negative then the Y will be 0. XOR gate is somewhat similar to OR gate, but when both inputs are positive then XOR gate will output as negative. So coming with MUX, what is MUX? MUX is also called multiplexer. It is supplied with two inputs. Here we have considered two inputs and one output. Number of outputs can be determined by taking log of the inputs with the base 2. So here is this is the select line and this is the truth table. When the select is 0 then the output is X. When the select is 1 then the output is same as that of Y. And this is demux. Demux is the complete opposite of mux. It also has select lines and input. The number of outputs will be 2 power inputs. So here number of inputs is 1, so number of outputs will be 2. So now what we will do, we'll start with the coding in the VS Code. But first of all, you should have downloaded this hardware simulator for NAND2TETRIS project. We will be running all our projects in this. So now we will code here. First we will code for AND gate. So what we will do, this coding is done in HDL. So let's start. So chip, first we will define the name of the gate, and input we are taking as A and B. Output is out. And what are the parts? Parts is first is NAND gate, where A equals A, B equals B, and out equals NAND. And NOT gate. To implement AND gate we require NAND and NOT, both of the gates. Input is NAND and output is out, right? So now we have written our code, we have saved it. Now let's check. So what we will do in this simulator, we will go to file, load chip, and we will select our code and.htl. we will load our chip. The chip has been loaded. Now script, we will load our script. We have loaded and.htl now, so we will load the same script and.tst. we have loaded, and now let's run it. So the code is running. Yes, and end of the script, comparison ended successfully. That means we have written our code very correctly. So now in a similar way we can write codes of other gates as well. So let's see of NOT. I have already written for not.htl, and this is input in, output is out, and what are the parts? Parts is NAND gate. NAND is A equals in, B equals in, out equals to out. So NOT gate can be made with NAND gate by combining both the inputs. So here it is how the code will work. Similarly we can go for OR, and here OR gates comprise of the parts NOT gates, 2 NOT gates, 1 AND gate, and then combining it with NOT gate. And similarly we will go for XOR. This is XOR. Input we are taking as A and B, output is out. Parts is, first we have taken OR gate. We have already made our code for OR gate, so similarly we can use it. Then we have used NAND gate. NAND is one of the basic gates, and then we have used AND gate. and A equals to A or B, B equals to A, and these are the inputs and outputs. right? So going with mux, yeah, you can see the code. We have written it in a similar way, and then demux, I think, yeah, we'll code for demux, fine. So again, same format, we will write chip, we will name it demux, right? And then input is in, and select line, as I told you, the select lines, output is A and B, and parts, what are the parts? We'll use not, input is select, output is select, then we will use and, A equals to B equals to in, out equals to A, and one more and get, right? A equals to select, B equals in, out equals B. We have saved the code, and now let's see if it's correct or not. We'll file, load chip, demux, we have selected demux, we have loaded it. Okay, line 3, there is mistake. Yeah, what is the mistake? Okay, this in, it should be capital, right? So again we will save it, go file, load chip, demux, yeah, it's correct now. Load the script, demux.txt, load script, and set it on fast, and then let's run it. Yeah, it's correct only. So it has been comparison ended successfully. So that's all for today's. These are the codes, and if you have any doubts, feel free to comment on this video. Thank you.